Okay, let us start the question number 21. What is the question is, if the radius of second stationary orbit is r, then radius of third orbit will be. What is the formula for this is Rn? Let us know the formula for this one is Rn. We know Rn is equal to n square a naught. Okay, from this second stationary orbit, okay, r n value is equal to 2, then put here 2 square a naught. Then the second stationary orbit, the second R2 is capital R dimension, capital R is equal to 4a naught. Then you got the relation like this, R by 4. Then the radius of third orbit will be okay, R3 is now third orbit for hydrogen atom. Okay, 3 square a naught. Okay, it goes to 9. A naught value is equal to R by 4. Then we may call it as 2.25, 9 by 4 value into R. So answer is D, 2.25 R, capital R. Next question, let us focus. Okay, which state of beryllium 3 plus has same orbit radius as that of ground state of hydrogen atom? Okay, let us write down what is the ground state of hydrogen atom radius. Okay, first of all, Rn is equal to, for Rn is equal to n square by z into R1. So for hydrogen like species, this is for hydrogen like species, H like atom. Okay, H like atom, this is for H like atom. We know R1 of hydrogen atom, value is 0.529 angstrom units. Okay, this is value is known as ground state of hydrogen atom, R1. So R1, you can straight away get this value. R1 is 0.529 angstrom units. Okay, then what they ask us is, which state of beryllium 3 plus has same orbit radius of that of ground state of the hydrogen atom? Okay, on which state it is equal to that radius? Okay, for that R beryllium 3 plus is equal to, we want to find out n square, compare this one, n square. For beryllium, Z value is equal to 4. Then R1 value is, okay, we know 0.529. Okay, which is equal to, they mentioned that which state, on which state the radius, the same orbit of radius as ground state of hydrogen atom is 0.529. Okay, okay, then we found out that these two are cancel each other, then n square gives raised to 4, then n is equal to value is 2. Okay, value 2. What we understand from this is the state of beryllium 3 plus has the same orbit radius as that of ground state of hydrogen atom. Ground state of hydrogen atom is like this, which is the radius of this one is equal to that one. Then what is the n value? N value like this we can find out n value is equal to 2. So the answer is B. Next, select the incorrect graph for velocity E in an orbit versus Z, uh, Z, comma 1 by n and n. So the values are missing here. Okay, let us correct it. Okay. Oh, select the incorrect graph for velocity E in an orbit versus Z, comma 1 by n and n. Okay, from this one, what is the aim of this is choose the incorrect graph. So from we have to find out the incorrect graph, then we know the equation Vn is equal to V1 Z by n. Okay, Z by n. Then okay, the relationship V and n. Okay, V increase. These two are inverse relationship. We know these two are Vn and n are inverse relation. So it will be correct one. It will be correct one. So it is correct one. Next, V 1 by n value. V 1 by n is Vn. Vn Z, you can write like this also. These two are proportional, so this is also proportional. This is also correct one. Next, V versus Z, velocity versus Z. These two are also proportional, so this is also correct one. So the remaining incorrect one is like this. This is the incorrect. There is no such relation V versus n like this. So according to this, incorrect graph is this. Incorrect graph is this. Okay, next question is what is the frequency of revolution of electron present in second Bohr's orbit of hydrogen atom? Okay, let us finish it. Okay, next question is what is the frequency of revolution of electron present in second Bohr orbit of hydrogen atom? Okay, for this frequency of revolution is frequency of revolution is equal to velocity in second orbit velocity in second orbit okay. Velocity in second orbit divided by velocity in second orbit is known as V2 divided by 2 phi r2. Then we have to find out V2. We know Vn is equal to V1 into Z by n. So V2, we have to find out V2. V1 is fixed value. That value is 2.18 into 10 to the power of 6. For hydrogen atom, Z is equal to 1. For second shell, N is equal to 2. Here N is equal to 2. Then it is 2. Then the value of this one is 1.082 into 10 to the power of 6. Then what about R2? R2 is equal to we know n square by z a naught. From this we know 2 square by 1 into a naught value 0.529 10 to the power of minus 10 meters. So from this, on consolidation, you can get 2.116 into 10 to the power of minus 10. Okay, you can get these two values, then find out the answer. Frequency of revolution is equal to velocity in second orbit 1.082 into 10 to the power of 6 divided by 2 into 5 value 22 by 7 into R2 value 2.11.6 into 10 to the power of minus 10. So you can get the value. You can substitute the R2. This one is R2 here. Then you can get the value 8.2 into 10 to the power of 14 second inverse frequency. So here the value is D. This is the value 8.2. This is the value 8.2 into 10 to the power of 14 second inverse. So let us correct it. 8, this value is 8. Okay, 8.2. So this answer is like this. Let us see again. The question is, okay, what is the frequency of revolution of electron present in second Bohr orbit of hydrogen atom? The formula is frequency of revolution for second Bohr orbit is velocity in second Bohr orbit V2 by 2 pi r. So you can calculate V2 and R2 value, then substitute all those things here, then you can get the value. So how to get V2 is, the formula is like one, this one is fixed value V1, and then substitute 1 for hydrogen, Z value is equal to 1 by 2. See, this is second shell. Okay, then you can get next one, you can get this value is also like this, Z is equal to 1 and is equal to 2. You can get this one and then substitute all those things here, then you can get the answer is like this. This is very simple question. Okay.